Welcome to Lesson 5 of Migration Mastery. Up to now, we've been doing translation work, converting Apache configs to nginx or back. This lesson is different. We're going to run both at once, with Apache out front terminating TLS and enforcing policy, and nginx behind it serving static files and proxying to your app. It's the less common direction, the reverse is more typical, and we'll cover that in Lesson 6. But when Apache's edge features are the right tool and you still want nginx doing the heavy lifting downstream, this is the pattern. Before we go any further, let's qualify when this pattern actually wins, because there are really only 4. 1. Compliance shops where policy literally mandates Apache at the edge: healthcare, finance, government. 2. You've got years of htaccess auth rules that are too risky to port. 3. You depend on Apache modules with no real nginx equivalent: Modi security with full OWASP CRS, Modi auth LDAP, Modi JK. And 4. You're mid-migration using Apache FRONT nginx back as a transitional phase to peel off routes one at a time. If none of these describe you, honestly, skip to Lesson 6. So if you're still with me, here's the mental model the entire lesson hangs on. Browser hits Apache on 443. That's where TLS terminates, where mod security inspects, where your .htaccess rules still live. Apache then proxies over plain HTTP to nginx on 8080. In cluster, no public exposure, no TLS overhead. And nginx serves static fast or proxy, passes to the app on 3000. Critically, Apache injects x-forwarded proto and x-forwarded 4, so the backend still knows the request came in over HTTPS from the real client. Memorize this picture. Everything else is just config that implements it. Now let's make that picture concrete with the Apache VOST. Up top, standard TLS termination, cert, key, modern protocols only, HSTS header. Then the proxy block, proxy preserve host keeps the original host header intact, and ProxyPass forwards everything to 127.a.0.180a80 over plain HTTP. The 2 request header lines at the bottom are the ones people forget. X-forwarded proto set to HTTPS tells nginx and your app the original request was encrypted even though this hop isn't. Skip those headers, and your app will generate HTTP JOX redirect URLs and break itself. Now flip to the other side of that hop, the nginx config Apache is talking to. The critical line is, listen 127.0.0 180.880e. Loopback only, no public interface, no TLS, no certificate paths anywhere in this file. Apache already terminated all of that at the edge, so nginx just speaks plain HTTP on a private socket. Then set real IP from 127.0.1 paired with real IP header x forwarded 4 rewrites remote adder to the real client IP, but only when the request actually came from the loopback, so nobody outside the box can spoof it. From there, nginx does what it's best at: serves static assets with a 1-year immutable cache and proxies everything else down to the app on port 3000. Now, that handoff between tiers only works because of an unwritten contract, and these headers are the contract. The moment Apache proxies inward, the original protocol, client IP, and port vanish from the TCP layer, so Apache has to re-encode them as headers, and nginx has to trust them. X-forwarded proto tells the app whether the user actually hit HTTPS, so it builds correct URLs. X-forwarded 4 carries the real client IP for logs and rate limiting. X-forwarded port preserves 443. X-real IP is the optional single IP variant nginx hands to the app. And X-forwarded host and X-forwarded server come along automatically when proxy preserve host is on. Apache sets, nginx trusts, app reads. That's the whole shape of it. So let's trace one real request end to end and watch that contract in motion. Browser opens TLS with Apache, sends get products. Apache terminates the handshake, runs its htaccess checks, stamps x-forwarded proto and x-forwarded 4, then proxy passes inward over plain HTTP, host preserved. nginx matches the location, sees it's not static, adds x-real IP, and proxy passes to node on 3000. Response travels back the same path. And notice the htaccess header on the way out. It's set by Apache, the edge, not nginx, not the app. The tier that owns TLS owns the TLS policy headers. Now that you've seen the contract work, the deeper question is, when does this layering actually earn its keep? 3 principles. 1. Each tier owns one job, so when something breaks at 3 in the morning, you know which config to open. 2. TLS terminates exactly once at the edge, with plain HTTP on loopback behind it. Doing handshakes twice just burns CPU for no gain. 3. You pay 1 to 3 milliseconds per request for that loopback hop. Invisible on a 200 millisecond API, painful on a 50 millisecond one. If 2 of these 3 resonate with your situation, you're in the right lesson. If none do, go single layer and skip ahead. So here's your debugging cheat sheet. When something goes wrong, this matrix tells you which tier to blame. TLS, the public port on 443, security headers, htaccess, mod security, all Apache at the edge. Static files and the proxy pass to your app on port 3000, that's nginx's job because it's faster at both. Print this next to slide 3. The diagram shows you the shape. The matrix tells you who owns what. When a header shows up wrong or a URL gets blocked, you'll know which config file to open first. Now, reading about this pattern isn't enough. You need it in your fingers. So spin up a test VM and work through 3 drills. First, build the layered stack from scratch in 30 minutes. Apache on 443, nginx bound to localhost 8080, node on 3000, and verify each tier with curl before chaining them. Second, prove the X-forwarded headers actually arrive at your app, tail both access logs, and watch the request flow through. Third, and this is the one that sticks, deliberately break it. Stop nginx, point ProxyPass at the wrong port, drop proxy preserve host, then read the error and learn the symptom. The intentional breaks teach faster than any reading ever will. Once you've broken it on purpose, you'll start recognizing the failure signatures in the wild. Here are the 5 that bite hardest. Bind nginx to 0.0.0.0 and you've just published your backend on the open internet, bypassing Apache, TLS, and mod security in one move. Forget X-forwarded proto and your app generates HTTP IJID links inside an HTTPS page, instant mixed content. Trust X-forwarded for from anywhere and attackers rewrite your access logs. Double redirect HTTP to HTTPS at both tiers and you get a loop. And skip proxy pass reverse and your backend's internal host names leak straight into the user's browser. Each of these returns a 200 somewhere. That's why they hurt. So that's Apache front, nginx back. You've mapped the topology, terminated TLS at the edge, contracted your headers cleanly, and split responsibilities between the 2 tiers. If this pattern fits your constraints, legacy Apache modules at the edge, htaccess-driven tenants, you now have a working blueprint. But for most of you, Lesson 06 is where you actually live. nginx out front, Apache behind, mod PHP doing the heavy lifting. That's roughly 70% of WordPress production stacks. Same mental model, flipped tiers. See you there.